Now, the last one is to go to the C question. So this one is for the B part. So the C question is telling me that I should show that the area of the finite region bounded by the curve, the tangent L, and the x-axis is 20/3. Now, how do I solve this particular question? Now, if you observe here that the shaded region extends to this point of intersection here, I have a point of intersection of this straight line with the x-axis. So, in other words, between this point of intersection is bounded by this point, and this point. Can you see the region? Right? But the shaded region is actually bounded by this point, and this point. So the shaded region is bounded by these 3 points, this point, and this point. That's the way it is bounded. Now, if I'm going to calculate the area or show that the area is actually 20/3, I probably need to get this coordinate here. Now, which is also a particular coordinate or a particular intercept on the x-axis for this straight line. So looking at it, this particular point of intersection on the straight line, for me, is actually going to be an x value, but the y value is actually going to be 0. So for this region, let me call it S. I'm going to have the S coordinates to be, first of all, a value for x, and the intercept on the y value is going to be 0 because it's an x-intercept. So what I'm going to do now, from this equation, y equals 2x plus 8, which is the equation of this straight line, I'm going to fix in the value for x to be 0 and get the fixing the value of y to be 0 and get the value for x. So I have 0 equals 2x plus 8. So I'm going to be having minus 8 equals 2x. If I take 8 to meet 0, that's 0 minus 8, that's minus 8. So x becomes minus 8/2, and that will give me minus 4. So I have now the value of x to be minus 4. So what I will do now is to tell you that the s coordinate there, the intercept on the x-axis s, has the coordinates of minus 4, 0. Right, so the next thing I'm going to do now is to get the area. And how do I get the area? I can only get the area by using the concept of integration. So I'm going to integrate the region. So I'm going to consider the straight line region. The straight line is actually going to be a region occupied from 0. You can see the region. So since this straight line is touching this region, so I'm going to consider this whole space. So I'm going to say for the straight line, which has an equation of 2x plus 8, this straight line here is actually going to be bounded, or let me just say I'm going to integrate this 2x plus 8 from the region of 0 to minus 4. Or let me just say from minus 4 to 0. From minus 4 to 0. Then for the curve, because the curve actually has a part in this shaded region. Let me just say this. The shaded region is actually above the curve, but it's below the straight line. So that's why we're going to be using two of them. But for the curve, you would observe that the point is actually from minus to 0. So what I'm going to do is that I'm going to call the first area A1, which is going to be the area of the straight line from this 0, or from area of the straight line from minus 4 here on the x-axis to 0. So I'm going to be having an integral from minus 4 to 0 of 2x plus 8. Since the straight line here has an equation of 2x plus 8. So integrating this, I'm going to be having x squared plus 8x, if I integrate that, Then I have 0 and minus 4. So I'm going to impute the values now for 0 and minus 4. So I'm going to be having 0 squared plus 8 times 0 for the first part. Then minus the lower limits now imputed as minus 4 squared plus 8 times minus 4. So at the end of the day, this will give me 0 automatically. That's 0 minus 4 squared is 16 minus 32. So I have 0 minus 16, and this automatically gives me 0 plus 16, and that's equals to 16. So for the straight line curve bounded by this particular region, so the A2, which is the second area, will be for the curve. So I'm going to take the curve is actually from 0 to minus 2 to 0. Minus 2 being the coordinate of FQ on the x-axis, and 0, which is the origin. So I'm going to have the curve going to be from minus 2 to 0 of 8 plus 2x minus x squared. All right, so integrating this one, we're going to be having 8x plus x squared minus x cubed over 3 from minus 2 to 0. So if I impute the values, I'm going to be having the first one 8 times 0 plus 0 squared minus 0 cubed over 3. Then minus, imputing minus 2, so we have 8 times minus 2 plus minus 2 squared minus, that's minus 2 cubed over 3. So that this one becomes automatically 0. So you have 0 minus 8 times minus 2 is minus 16 plus minus 2 squared is 4. Then minus, this will give me minus 8 over 3. Because minus 2 cubed is going to give me minus 8. So I'm going to have 0 minus minus 16 plus 4 plus 8 over 3. Automatically gives me minus, into bracket, minus 16 plus 4 plus 8 over 3. And that will give me 16 minus 4 minus 8 over 3. Right? And that should give me 12 minus 8 over 3. And that should give me 3 times 6. 3 times 12 is 36. 36 minus 8. So that will give me 28 over 3. So for the second one, I have 28 divided by 3. Right. So the first area gave me 16. The second area for the curve gave me 28 over 3. Now, how do we bring the two answers together? Because the region is both bounded by this straight line and this particular curve. So how do we bring them together? So bringing them together to get the total area. You get the total area now. The first area, A1, is 16. This is for the straight line. Then A2 is 28 over 3, which is for the curve. So what we're going to do now, the total area, which is A, is actually going to be A1 minus A2. The reason is A1 minus A2 is because for this straight line, right, the shaded portion is below the straight line. The shaded region is below the straight line. So whenever it's below the straight line, the integral for that particular curve or line or anything is always positive, right? But whenever the shaded region is above the curve or the line, like in this case, above the curve, if you observe, you can see it. It is already integral is always negative, so that's why I'm putting minus. So at the end of the day, I'm going to be having my area. A1 is 16 minus 28 over 3. So at the end of the day, 3 times 16 is 48. 48 minus 28 divided by 3. And that will give me 20 over 3. And that's how the area equals 20 over 3. So That's all about this particular question. I know it might be looking very long because of some of the analysis, but you can go back, play the video, and see how you can actually understand the concept. So talk about some other questions some other time. But for now, stay blessed. Thank you.